In this video, you will learn how to find the probability of independent and dependent events and how to find a conditional probability. Let's start with the probability of two independent events. If two events are independent, but you need both events to happen, that would mean we need both events A and B to happen. So I would take the probability of A and multiply by the probability of B. This is what we've been doing all along. So let's look at example 1. In example 1, we want to find the probability of getting a sum of a 5 of the first toss of 2 dice and a sum of a 3 on the second toss. So for getting a sum of 5, let's look at our deck of cards sheet. Again, at the bottom here are 2 dice possibilities. So starting with getting a sum of 5. If I look, I'm going to get a value of 5 if I roll a 1 and a 4 or a 2 and a 3. And that happens 2 places. And so that means I would have the probability of getting the sum of a 5 4 times out of the total 36. So because it says we want the probability of the sum of 5 and a sum of 3 for the second toss, these are 2 different tosses, 2 separate events. So they are independent, but also the and means that I want to multiply these 2 probabilities. So now let's find the probability of getting the sum of 3. So I would get a 3 whenever I rolled a 1 and a 2. This happens 2 times out of the total 36. And so now if I multiply these 2 individual probabilities, since these are independent events, and again I need both to happen, 4 times 2 is 8, 36 times 36 is 1,296, and this would simplify to 1 over 162. Please now pause the video and complete example 2 on your own. In example 2, there were 9 boxes of brand A and 6 boxes of brand B. Person 1 was going to select brand A 9 out of the 15 times. If he puts it back, and that's the key word, he replaced the box he took, then when person 2 comes along, they also have a chance of 9 out of the 15 that they take brand A. Because these are independent, since we replaced the box, that means I want to multiply, and so I would simplify down to 9 over 25. Now, again, example 2 was independent because he replaced the box. A lot of the times, though, we have things that are dependent. Whenever you do not replace something, that is dependent. So let's look at the probability of 2 dependent events. The probability of 2 dependent events is again going to be multiplication, and we need both to happen. But when you're figuring out the probability of the second event, you have to take into account that event A has already happened. So let's look at example 3. It says that Tom has 10 white socks and 8 black socks mixed in a drawer. One morning he randomly pulls out 2 socks. What's the probability that he will select a pair of black socks? So let's start with the probability of the first event. The first sock that he takes out is a black sock. So since there are 18 socks total, 10 plus 8, and he wants to take a black sock, so 8 black socks. The probability that the first time he's going to get a black sock is 8 out of 18. And so we need to multiply. We want the probability that the second sock is black. Now what you have to keep in mind here is it says he pulled out 2 socks. So we are not replacing the first sock. That is actually what is making this dependent. And so when he goes to pull that second sock, since we've already taken 1 sock out, now there are only 7 black socks. And remember, we've also taken one sock from the total. So there are only 17 socks total. And because, again, both events need to happen, and that's why we're multiplying. So if I now multiply 8 times 7, I'm going to get 56, and 18 times 17, 306, and this simplifies to 28 over 153. Let's now look at example 4. In example 4, we're referring back to example 2 from above. Adam is going back to the grocery store. If he did not replace the one box he took, what's the probability that both people would select brand A? Pause the video and complete example 4. In example 4, again, we were not replacing, so that made dependent. So the probability that person 1 takes brand A is still 9 out of 15. There are 9 brand A's to begin with and 15 total. But the probability that person 2 takes brand A, given the fact that person 1 already took one box, means now there's only 8 of brand A left, and there's only 14 total left. So multiplying the 9 times 8 gives me 72, and the 15 times 14 is 210, and that simplifies to 12 out of 35. Please now pause the video and complete examples 5 and 6. Notice in 5, you are not replacing the card before you select the second card, but in 6, you are replacing the card before you take the second. So in example 5, since we did not replace the card, when I was finding the probability of getting a black card the first time, there are 26 black cards and 52 total. But since I didn't replace it, when I pull my second card, now there are only 25 black cards and only 51 total. Multiplying those and simplifying gave me a probability of 25 out of 102. In example 6, since we are going to replace the first card before drawing the second, these are now independent. The first time I draw a black card, there are 26 black out of a total of 52. And the second time, there are 26 black out of a total of 52. That multiplies out and simplifies to 1 over 4. Let's now take a look at example 7. In example 7, I want to find the probability of getting one red card and one spade in any order without replacement. So there's two special things going on here. Because it is without replacement, this is going to be dependent. The other special thing going on here is it says we can select them in any order, meaning we have to account for drawing the red card first and then the spade, or drawing the spade and then the red card. So that means we're going to have to do two different places here. So let's look at the first situation where we draw the red card and then the spade. The probability that I'm going to draw a red card is 26 out of the total of 52. And the probability I'm going to get a spade, given I've already selected a red card, would be 13 out of 51. Because there are 13 spades and none of them are red, so I don't have to worry about that. But now it's only over a total of 51 since I have taken one card away from the total deck. Or means addition. Let's now look at the second situation. We want the probability of drawing a spade and the probability of getting a red, again knowing that we've already drawn a spade. So again, there are 13 spades out of all 52. And means I multiply. But now there are 26 red cards, but remember, we've already taken one away. We did not replace. So out of a total of 51. So if we calculate this all out, we're going to simplify to 13 over 51. Please now pause the video and do example 8. In example 8, notice that again, you are not replacing, And here we are doing the cards in a specific order. So you don't have the second possibility to worry about in example 8. You'll notice we basically just took this first situation and multiplied them and simplified. And that gave us 13 out of 102. Let's now look at the second page where we're going to toss a red, a green, and a yellow die. In example 9, we want to find the probability that all 3 dice show a 4. Keep in mind that each time we are throwing a different die, and so that makes these events independent. So all I need to do is find the probability that the red has a 4, the green has a 4, and the yellow has a 4. And so since each die only has 1 4 but 6 numbers, each one is going to have a 1 out of 6 chance of getting a 4. So since I need all 3 events to happen, we're going to multiply, and that multiplies to 1 out of 216. Let's now look at the example below number 11, and then you can do 10 and 12 on your own. In example 11, we're asked to find the probability that the red die shows an even number and the other 2 show a different odd number. Because we need the other 2 to show a different odd number, that makes this dependent. So let's start with what we're throwing. We want the probability of an even and the probability of an odd and the probability of a different odd, given there's already an odd. So there are 3 even numbers on a die, 2, 4, and 6. So 3 out of 6 is the probability that I get an even. And, so multiply, there are also 3 odd numbers. Now, what we have to remember when we find the probability of getting a different odd is that there are 3 odd numbers, but we've already chosen one, and we cannot re-choose it. So there's only 2 possibilities that we can have for this event to be successful when I throw the second die that's to give me a second different odd number. But remember, on that one dice, there are 6 possibilities. It's just that only 2 of them will make us successful with a different odd number. So now if I multiply these out, I am going to get 18 over 216, which simplifies to a 1 out of 12 chance. Please now pause the video and complete examples 10 and 12. So in example 10, we have an independent event because each die is going to be thrown separately. There are 5 values on a die that is not a 4. So each time we have a 5 out of 6 chance that all 3 are not going to be a 4. So multiplying that out, you get 125 out of 216. Now in example 12, this one is dependent. It's dependent on whatever the first die's number is. So when I throw the first die, that just has to give me a number. So we have a 6 out of 6 chance that when I throw that first die, I get a number. The second die, though, has to match. So there's only one chance that that is going to be the same number as the first die. But remember, there's 6 sides on that die. It's the same thing for the third dice, a 1 out of 6 chance. So multiplying those out, I get 6 out of 216, which simplifies to 1 out of 36. The last kind of probability we want to look at is conditional probability. So conditional probability happens when you have certain conditions that must occur before the actual event that you're trying to find the probability of. So the way that we write this is the probability of A given B. And the way that you calculate it is you have to find the probability of both events A and B happening divided by the probability that event B actually happened. So the second event, the condition. So in example 13, it says a pair of dice are rolled. Find the probability that the dice match, given their sum is greater than 9. So this given that their sum is greater than 9 is the condition. The probability that the dice match this would be the first event A that we are actually trying to find the probability of. So again, let's look at our dice sheet and see what we have. So on our dice sheet, we are trying to find the probability that we get doubles, and again, that the doubles sum is greater than 9. So here's all the places where we have doubles. We have doubles at 1, 1, 2, 2, etc. Of these doubles, there are only 2 sums that are going to be greater than 9. We also, remember, have to meet the condition of the probability that the sum is greater than 9 when we roll 2 dice. So let's look at all the places where the sum is greater than 9. Now greater than does not include 9, so we'll start with values that are 10. So it looks like there are going to be 6 times when we have a sum greater than 9. So let's now take that information back to our example. So the probability that we get doubles, given that the sum is greater than 9, would break down into the numerator the probability that we have doubles and we have a sum greater than 9, which we said happened 2 out of the 36 times, divided by the probability that we get a sum greater than 9. So that we said happened 6 out of 36 times. If you simplify this compound fraction, either in your calculator or multiplying by the reciprocal, you should get a value of 1/3. If you are going to use your calculator, make sure you use your parentheses correctly. What I mean is every time I enter a fraction, I always put that entire fraction in parentheses. This way I keep the 2/36 in the numerator and the 6/36 in the denominator. Then I can make my decimal a fraction by doing math, and the first option is frac, and pressing enter to get the 1/3. Please now pause the video and complete example 14. So in example 14, the condition was it had to be a spade. So what we were trying to find was that it was an ace, knowing that it's a spade. So that means I need to take the probability in the numerator of the card being an ace and a spade, my condition, and divide out the probability that the card is going to be a spade. So there's only one card that is both an ace and a spade out of a total of 52. But in the denominator, there are 13 spades out of the total 52. Again, either by multiplying by the reciprocal or using your calculator, you should get this to simplify to 1 out of 13. The next 2 examples can be any of the probabilities we've discussed. Please pause the video and complete example 15. So in example 15A, we just wanted to know what's the probability that a student is female. So we need the total number of females divided by the total number of students. There are 80 plus 40 females, and for the total number of students, I had to add all 4 numbers up. 120 over 200 simplified to 3/5. Now in B, we said if it's female, what's the probability that she is full-time? This is conditional. We first had to meet the condition that she was female. So I needed to find the probability that you were full-time given you're female, and there's only one value where you have both full-time and female, 40 out of the total 200. Then we need to divide by the probability that we are female. So that's 80 plus 40 divided by 200, or 120 over 200. Again, multiplying by the reciprocal or using your calculator, you should find that if she's female, you have a 1 out of 3 chance that she is full-time. Please now pause the video and complete example 16. In example 16, you had to find the probability that the male favored, which they said up here was 50 out of 75, and multiply that, because it was and, the probability that the female favored, which they said right here was 40 out of 50. If you calculate that out, you should have gotten 8 out of 15. Please now complete the next 2 assignments for this section.